All right. I think we're almost ready. Let me keep doing. Okay. Hide this. Make sure that I'm paused so I don't hear myself, and make sure the volume is gone there. Okay. So today, well, let me do introduction, I guess. Actually, let's start there. Hey, get down from there. 1 second. All right. Cat's ready for the stream. Okay, so quick introduction. Hello, everyone. My name is Tim. I go by foamyguy online. In this stream, as you may know, if you've seen it before, we work on CircuitPython related things. If you're brand new to the stream, if you don't know anything about it, haven't seen it before, and you don't know what CircuitPython is, it is, you can find out more at this webpage here, circuitpython.org. But a brief high-level view of it, CircuitPython is a version of Python that runs on tiny computers, like there's one embedded inside of this lightsaber here, and you can write Python code for these tiny computers and manipulate things like lights, LEDs, RGB lights, speakers. You can make beeps and boops and all kinds of sounds. You can play with MIDI devices. You can hook up to external sensors, breakout boards, and all kinds of things like that. So, basically just little computers that can interface with real world sensors and outputs and things like that. So there's a bunch of different examples of shapes and sizes of them that are in the background of this page here. Again, this is circuitpython.org, so if you want to learn more, you can head there. In this stream specifically, and actually let me mention also, if you want to help contribute to CircuitPython, there's a couple ways you can do it. If you click on this contributing link up here, it's going to take you over to a list of all the open pull requests and all of the open issues across all of the CircuitPython libraries. So CircuitPython is made up kind of 2 or 3 main sort of different components that make up the ecosystem. One of them is the CircuitPython core, which runs on those microcontrollers. Another one of them is the CircuitPython libraries, which are Python coded libraries that can run on these devices as well and give you access to all sorts of different hardware and all sorts of other helper libraries that allow you to do different things, like with displays and Adafruit IO and all sorts of stuff like this. So if you want to help contribute, again, this is the place where you can find it. Another way that you can contribute if you're not interested in actually helping out with the code side of things, because everything is open source, so anyone who wants to can help out with the code. But if you are interested in the project but don't want to contribute that way, another thing that you can do is just purchase hardware from Adafruit. Their website is adafruit.com. This is the company that is the primary financial backer for CircuitPython. So they pay folks full-time to work on the CircuitPython project and foster the community and do all sorts of things around the project. So if you purchase hardware from them, you are indirectly supporting the project since they are paying the folks who are working on it. This stream is not like a paid advertisement. They're not paying me to promote their website right here. They do pay me sometimes to work on software and to make guides, but this is just a thing I do myself. But I definitely, really like the project. I really want to, see it succeed for the foreseeable future. So I always like to mention up top that this is one of the ways that you can, help out is by purchasing hardware from them. So that's their website here, adafruit.com. You can check out all the different things they have. Essentially they sell lots of the different microcontrollers and they sell lots of different things that you can plug in and do with the microcontrollers. So today, what I want to look at is 2 main things. The first one is I'll be picking up where I left off last week on the missing type finding tool. So last week we started working on a couple of different scripts and things that will help us basically look at all of the library code and find any functions that are missing typing information. So if they don't have declared like what type the arguments are supposed to be and what type the returns are supposed to be and things like that. And these tools, there's scripts and things that will allow us to create an issue on every library that is missing typing annotations or information, and then we'll post that issue. It will get tagged as a good first issue, and then coming up in the month of October, it will also count towards Hacktoberfest. So if folks are interested in getting involved in the project during October, there is the Hacktoberfest. Maybe we could pull up the page for that, which is like a yearly thing that, I don't know, is it sponsored by GitHub? I'm not sure. Hacktoberfest. I'm not sure. Whoa. I'm not sure actually who. DigitalOcean, maybe? Hacktoberfest, yeah, it looks like hosted by DigitalOcean. So the idea is like, it's I don't know, it looks like, I guess they must have done it in person for a while, but I think it's, of course, probably been, remote, virtual for the last couple of years. But basically the idea is during the month of October, you can work on open source projects, and you earn, I don't know if they tabulate points or something like that. Somehow you can earn, credit for working on these open source projects, and then I think you can turn it in maybe and get a shirt or some stickers or something like that. I'm not 100% sure of the exact way that all of that works. I've never specifically participated as a a person that's contributing. I've been kind of aware of it for a few years, but not something I've done personally. So if you are interested in any of that stuff, you can look into it. Looks like we're on here, hacktoberfest.digitalocean.com. They got a nice countdown running to the beginning of October. So again, our goal is going to be to try to create all these issues before October, and then they'll get marked as Hacktoberfest so that folks that might be involved with this this festival, this effort, will be able to find them easily and work on them. Even folks that are brand new and who have never contributed to CircuitPython before. So that's what I'm going to start out with. I kind of had planned to work on it a little more throughout the week, but some other things popped up. I worked on some stubs. I worked on some stuff in the cookie cutter, some different things like that. So I did not end up with time this past week to work on the script that we left off with last time. So I'm going to start with that. And then after we get that working, the next thing I want to dive into today is this branch that Les Samurai Perpe has started. So this is inside of Blinka Display.io, which Blinka is the CircuitPython compatibility layer that runs on Raspberry Pis and other single board Linux-based computers. And in fact, is usable to some extent on any Linux-based computer. Not everything is usable on just a standard like Linux PC, but some of it is. And Blinka Display.io specifically is the port of the CircuitPython display system called Display.io that runs inside of Blinka. So Les Samurai started this up, looks like around a week or so ago, or I assume maybe has been working on it longer than that and just published the issue. I don't know. It looks like there's a lot that's been done already. So there's some background on it here. They started out trying to translate this display core concept from inside of the actual CircuitPython core out to Blinka Display.io, and started realizing that it was going to be a little bit larger than that, and it kind of turned into a full rewrite of Blinka Display.io with some really interesting new features, at least new to Blinka Display.io, like access to Vector.io, which we did not previously have, and also bitmap tools, which is a bit of a newer module, which we also did not have access to in Blinka Display.io. So this caught my eye last week, and I'm really excited to dive in and try some of this stuff out, especially some of these newer things, and also just do some testing generally on this branch. So that'll be the second thing that I work on today, I think. So we will start with the type stuff. So what I'm going to try to do is actually just write this script. Last time, if you caught the stream last week, I wrote out kind of pseudocode here for this sort of hypothetical script that could run on each one of the library repositories, but we have not made it into actual code yet. So let's try to do that. I think, no, that's all right. Thank you. Let's go for a ban on that one. All right. I I talked about a little bit last time, either making this a shell script versus a Python script. Sorry, I don't know if that came through. That might have been kind of loud. Still wrapping up my my coffee. Let me chat back here as well. Okay. So, you know, I certainly have a lot more experience with Python scripts than I do shell scripting. So it'd probably be easier for me to write most of this as a Python script. Yeah, I think I'm gonna try it as a Python script. If we run into some kind of issue where it seems like it's gonna start looking easier to be a shell script, then maybe we'll change it up. But for now, I'm gonna start as a Python script. And what do we want to name this? This is I mean, we could just stick with run on each. That's kind of a weird name, but it'll do for now, I think. Run on each. Let's see here. Yeah, we can add this, and I'm just going to go side by side with my pseudocode here and then kind of just start implementing this stuff as it's written in the pseudocode. So copy these files into the root of the repo. So let's see here. I think we should be running, I believe the context that we're in. Nope, I still don't. Thank you. That'll be another ban. Okay. I believe the context is, it should be in the root of each repository. So I think what I'll start out with is, let's just prove that we are actually in the root. That way we will be able to write the rest of this and be confident about what it's actually going to do. So we're going to import OS. We're going to say, do we have to print? Let me see if we have to print. Import OS. Well, we're not in Python. Python import OS. os.system ls /. Okay, yeah, now that prints for us. Okay, so let's go quit. Let's go, we don't have to print, so os.system. We'll just do that same thing. We'll check if we are actually in the root of all these repos, which I suspect we should be, but you know, we got to find out for sure. Okay, so I'm gonna open up the bundle as well, and actually I'm gonna get a fresh copy of the bundle. Bundle GitHub. Fresh copy of this. So we'll clone it. We want to put it inside of here. I don't want to. Yeah, I think I'm just going to put it inside of here. What I'll do is I'll make a directory bundle, but I'll add this to git ignore so that it will not get checked in. Oh, but then we'll have a git. Yeah, then we'll have a git repository inside of another git repository, which I think it doesn't like so much. So let me not put it in here, I guess. What we'll do is we will, let's see here. This is connected to the Raspberry Pi. Let's, repos, CircuitPython. Is that, I don't know why it wasn't finding. Is this type or case sensitive? Yeah, there we go. Okay. Let's go bundle type search. Make a new directory for this, just to, because it's going to be adding files and doing different things. I don't want to leave all of those files in the copy of the bundle that I use, like for making pull requests and stuff like that. So bundle type search. We'll go git clone. Okay. We need to get all the what are they called? Not subrepos or what are those things called? Submodules. I think they're submodules. There's 2 commands for it, and I still have not committed them to memory. So I come to this page and I find them and I run them from here. One of these days I will actually commit them to memory or make an alias. We need to go inside. Should make an alias is what I should do. There we go. Okay, so this is gonna download all of the bundle, all the libraries that are inside the bundle. And I'll open this up in PyCharm as well. Bundle type search. I think we'll just open up the actual bundle directory as well. A new issue or new window there. This does take a second because it's gonna clone, like, again, every library that's inside the bundle. I think we're up to, I don't know, maybe over 200, something like that. So take it a second to run. And I think what I'll do basically is we'll just take this run on each. I'll copy this and we'll put it in the root of this. No, we don't want to add it. Let's see, is this finished? Not quite. We're into helpers, up to H in the helpers. All right, we're getting close. We're down to the T's. There we go. We'll print all of this stuff for us. Alrighty, now we are done. So we can get rid of this for now. So let's go. No, this is not. Let's go. History, grep for each. I think it's something like this. Yeah, okay. So get submodule for each, and then we put our command in quotes. So let's copy that. Let's get some quotes here for each. We're going to run for each Python. And I guess if we're inside of each repository, we would need to go up some, I think, right? We would be like inside of here, essentially, for each different one. So we would go up one to get to either helpers or drivers, up another one to get to libraries, and then up one more should get us to bundle, which is where this is at. So is that three up ones? And this won't have tab completion, unfortunately. Okay, let's see if that works. Yeah, that looks like it's working. So this is basically, and obviously we can't read this while it's scrolling past, but it will finish up here. And what this did is it ran, essentially it ran ls inside of each one of those libraries. And all of this does look correct. This is all the exact stuff that we wanted to see inside of there. So I think let's make one more directory here. Find type finder scripts. And I suppose we could put this inside there, then we would just need to type out more stuff. But what I will do is I will take these things and we'll put them inside of that type finders directory. So find the missing annotations, make the issue, make issue description, and we also need the template, which is templates issue template. So we'll put all of this inside of here. Well, we'll try to at least. Doesn't seem like it wants to. Copy. Copy. Copy, copy. Paste. Okay. I don't know. Copy from here. Paste. We don't want to add them. Okay. So now we have type finder scripts inside of here. And if we head back to where our pseudocode is, we basically want to copy all those files that we just put into that directory into the root of the repo. So let's comment out the ls. Maybe we'll come back to that afterwards. Yeah, we'll comment it out. Maybe we'll come back to it. I'll put some stuff before it, because I guess it would make sense if we change things and then ls afterwards. Let's go. We want to use OS to copy? Yeah, I think so. No, not ls. Copy. So this would be the same thing. We would want the 3 ups, and then we would want all of the things inside of type finding. Type finder scripts. Type finder scripts. And we could do copy /star. We want star. We want everything inside of it. We want to put them into the place where we are currently at, which should be the root of the repository. Okay, so let's run this one. Well, we'll need to take this and put it into here, because this is the one that's actually running. So let's run this and see if everything gets copied in correctly. No, not working. Omitting directory templates. Okay. So we need -r. -r. There we go. So it looks like it's working. We could check it out by going libraries, drivers. Let's look in the first one. Yes. Okay. We have find missing type annotations. We have make issue. We have make issue description. We have templates. So all of those, there's now a copy of all of those in the root of every one of the libraries. So getting back to here, what's the next thing of our pseudocode? Determine if it's a package or a single .py file. Let's see. How do we do that? I think we can check. So we know the name of our own scripts. And we know that we should expect to see a setup .py. So I think we'll do a listdir on the root, and then if we find a Python file, a .py file that's not setup.py or either of the ones that we pasted in, then that is the module. That's the thing we want to type check. If we don't find a py file other than setup.py and the ones we copied in, then we know that that library is a package. It's going to have a directory, and we're going to have to figure out which directory it is, but we'll get to that afterwards. So let's go. So let's make a list of known .py files. Known .py files is a list. Setup.py. Find missing type annotations. This is going to be kind of wide, I guess. Let's make it like this. Make issue description. Okay. So if we find a .py file that's not one of these three, then that's the one. That's the one we want to check the types on. So files, repo files is os.listdir./ if I guess we need to loop, I guess, right? We need to loop, I think. For file in repo files, if file ends with .py and file not in KnownPI files. This is going to be, I don't need quite so much space, do I, here? Okay, we want a variable to hold the library file. Do they call that a module? What is it? Package or module? Module. Okay, py module. Lib module. We'll start on none. Start on none. If we found a py file and it's not one of the known ones, then lib module is file. And if we got to here after the for loop and lib module is none still, print this library is a package. And yeah, let's go else. If it was a module, then print the module name, print lib module. Okay, so this will loop over all of the libraries. It will try to find the correct module file. If we don't find it, we'll print this generic message. If we do find it, we'll print the name of it. And yeah, we can skip copying these for now. Eventually we'll turn that back on so that we're always copying in the latest versions, but it might save us a little time, maybe, to not need to copy them. So let's run it. And it looks like it's working. We'll wait for it to finish, and then we'll go through and just double check that list, this should be this. Doesn't really matter though, right? It's just a print statement. So we found, it looks like, the correct py files on the ones that have py files. And some of them we found that it's a package. So let's just double check one of these here. to make sure that it is in fact a package. So let's say register, which is in helpers. Register. There it is. Adafruit register is definitely a package. Okay. So now let's find the library package if it is a package. So inside of here, we will loop again. How do we check if it's a directory? How do we check if it's a directory? I don't know. Isdir? Is there like an Isdir? Python OS Isdir? Seems relevant. Isdir. Check whether the specified path is a directory. Okay. Do we need to import os.path, or we should have it already, right? Python import os.path .isdir .slash. Okay, yeah, we don't need to import os.path. We can just import os. So if os.path.isdir file, so if it is a directory and file not in known dirs, which we don't have yet, we'll make lib package equals file. We'll make a lib package. We will make a known dirs. So these will be .github, docs, examples, licenses, templates. That's it. GitHub, docs, examples, licenses, templates. So if we find a directory that's not one of those, then we know that the directory we found is the library package. So then this library is a package. So then let's go out here. If lib package, then print lib package, else print lib module. Okay, so this one should now print the package name or the module name for each one of the libraries. So, yes, turtle is a module, it printed. Tiny Laura is a package, and it found it. WSGI is a package. Let's just again double check. WSGI, yep. Waveform, yes, as well. Okay, that looks like it's working. So now we have essentially the argument that we are going to run MyPy against. So at this point, we have now done this. We want to run find missing annotations on the package or the single file. So does this find missing annotations? So it's a function that accepts either it says path to module. It would actually be the package or the module. That's all right. I think so. We could import this, right? Because there should be a copy of it in the same place we're at. Be a copy of it there already. So here we should be able to say from find missing type annotations. Whoa, why are we searching? Okay, so it's okay, here's what I'm gonna do actually. We're gonna go back to working in this repository because this will know where it's at. Except we want from import find missing annotations. Which returns a list. This returns a list. So we go missing type, missing types equals find missing annotations, and we will, I guess we need to do this inside of here, or else we need to make MyPy target. MyPy target. My target is the package. MyPy target is the module. MyPy target. Okay, missing types. If it finds any results, if the length is greater than 0, if length of missing types greater than 0, let's just print missing types for now. Missing types. Okay, and we can put that back into our bundle. So this one, let's take out actually this print. Yeah, let's take out that print. Let's just have it print the missing types. And it's going to print a lot of stuff, I'm sure. Nope, it's going to not do anything. So no module named. Module named. Find missing annotations. So I guess we should not keep this at the root. Instead, we should just put this inside of here so that it's going to get copied into the root of each repo. Why does this think it's in Git? Does this think it's in Git? I don't know why this is not red. Okay. So well, but the problem is run on each is what puts all of those things into the root. So it can't run to put itself in the root. So maybe we'll do copy type finding files. And let's put this and this. Inside of here. So this will copy all the files over now. And then after we do that, we would then run on each. Copy type finding files. Never mind. Type finding files. Then we can just do this, right? Python. Need a space. Python run on each. That work? Oh. So did we get our copy correct? Let's check that. Yeah. And this is, what's the actual error? Type error. Expected string. Bytes or path, not none. Line 8. Not none. So let's turn these back on so we see if we actually printed it. And let's, well, actually let's do, let's turn these back off and let's do print MyPy target. None. Let me see those all get printed. Instant save. None. Why do we have 2 dots here? This should be dot slash, right? Yeah, I don't know. I must have added a second dot somehow. Okay, cancel, cancel. So the problem is, yeah, cancel. Can I cancel? The problem is we need to add run on each to this. Run on each .py, because now we have another file, which we also want to ignore because it's definitely not the one we're looking for. Okay. Why does this not find this now? Inside type finder scripts. Not sure. Okay. I don't know if that will make it not work when it actually runs in the real context. I would prefer it be able to find it in my editor here. It doesn't matter. It seemed like it was finding it anyway when it ran this way, but no. No known parent package. Okay, so that does break it. So we'll sacrifice the red wavy lines here and just anyway. Okay. So it seems like it's running. I'm gonna stop it though because MyPy cache. We don't want that. That's a, and so it's going to create one of those whenever it runs MyPy. So, well, I assume that's interesting. It didn't find that for this one. Only this one. I don't know why this one had a had that already. My cache. Huh. Okay, no problem. We can just add that to known directories. MyPy cache. Why are these saying fruit? It can't be right, can it? Yeah. Okay, so once we account for MyPy cache, it seems like this is pretty much kind of working properly. It's finding each instance of missing types, and it's building this list, which is what we will eventually feed into our template. So things seem like they're working okay, but we're missing the Ada from Adafruit, it looks like. So let's see why. Probably we assumed like a ... and we removed it or something like that. That sounds kind of familiar. Let's see. Yeah. So we just take that out. Check that out. Yeah, let's take it out and try it. Okay, I'm gonna cut it before it goes too long here. Yeah, that's looking pretty good. Pretty good. So now let's just go verify the results that it found. Line 42 inside of here. 42 init. Yeah, does not have pipe annotations there. Or doc strings, actually. 56. No type strings here. You know, this one would be Boolean. Doesn't return anything. So it would be like arrow none, I guess. 61. This one doesn't have any arguments. But it should still say, I think, return none, probably. Like this. In fact, let's fix a couple of these and just make sure that they don't show up in the list anymore. And value false. I don't remember how to do that. Is it colon? Python typing annotation? How does it work if it has a default, though? Does our one in the template have that? Yeah. Kind of. So colon type and then equals value. Colon Boolean. No. Boolean. Hmm. Yeah. And types bool. Bool. Okay. Okay, so 56 and 61 should not get flagged anymore, I don't think. So these two should be gone from the list if we run again. And I'll cut it early again. Perfect, yeah. 42 still got flagged, that's a nit. But 56 and 61 are no longer in the list. So we got those fixed. Of course, I'm not gonna make the PR and do all of that stuff with that now. This is what will make the issues to point these out, and then other folks will make PRs for them. But this does prove at least that once it does get fixed, it will no longer get flagged by this script. Okay. So we're really pretty close here. I don't want to run make issue yet, so we're going to leave that part out, but pretty much everything else I want to do. So we found the missing types. If the length is greater than 0, we need to print them. I think what I'll do is just found print found number missing types in how do I get the name of the current directory? Let's get CWD. Okay. I don't want the whole beginning of it. Format. So length, missing types, os.get current working dot split slash last one. Okay. So we'll print the number that we found and the library directory we found them in. And let's also then pass the results to make issue description. So here, we need to make this more modular. Name equals main. So we'll put this inside here for testing, but really what we want is make issue function def make issue description. It accepts a list of missing types. Opens the template, turns it into a template object, renders the text. But we don't want to call this anymore. We just want to use the list that we got passed. Missing types. That was name. Yeah, I'll do that for now. We should change this part in main to call this function instead of do the same stuff, but give that a better name. Okay, and like I said, let's go ahead and fix this. Issue description. Missing types. Okay. We don't need any of this anymore. This wants another line. Is this? Doesn't return anything. Yeah. It's true because it does the side effect. Just makes the file. Okay, so this would probably fail. This fail? I guess this might work. This might work still. If we run this, does it work still? Finished. Missing types issue. Yeah, it seems like it works still. Okay. So another thing we were gonna do is I did get feedback from Kattni. We'll tweak the tweak some of the wording. I think I'll just try to get this to run first though. Got one of these, but it might not work for a front light. Lots of dots in the plexiglass. Not sure what that's related to. That's all right though. Responded to an older message. It seems like this would work. So let's grab this code. Update the one that's in here. Just gonna close a bunch of these. Okay. And so we need to import make issue description. From make issue description, import make issue description. And then we just say make issue description missing types. Okay, so this would generate a new text file inside of each repository, each library repository. Did I just do that wrong? Okay. All right. So I'll start this one up, and as long as it looks like it's working, I'll let it run. That way we can also maybe get an idea of about how long it's going to take. So while it's going, I'll go and check the first one. Yeah. It's got our fixed ones removed. That looks like the same list we got before. That's looking good. If we wanted to get extra fancy, we could try to link these in GitHub to that line, but that's maybe a step more than we really need. Folks can just find the file number there, or the the line number. All right, so it does seem like it's going to take it a minute to get through. Ooh, lots of them in there. Got our slashes for init because of the markdown. Actually, this one has a lot. We're in the L's, M's of drivers. Drivers is before helpers. We're maybe halfway through drivers right now, I think. Somewhere around there. Hands. All right. Pull the chat back here. Okay, where are we at? We're up to RFM, so we're getting towards the end of drivers. Pretty sure my terminal has a thing that'll tell me how long this took when it's done. So that's kind of the main thing I'm waiting on, is I want to let it finish and then just have an idea of how long it's going to take when we actually run it. Let's see. I like to like to be able to run it on like 2 or something like that. Not very many, like 1 or 2 with the make issue. Not sure of a great way to do that though. I guess if I had a modified bundle with most of the libraries removed, or the other thing is I could just Control C, I guess, right? Exit out of it. We're over to helpers now. Oh. Test. This is wrong. This is wrong. The map font. Yeah, we need to put test into here. PyCache is also wrong. We need to put that. We don't want that. Can I not highlight this? Oh. Let's use Control C to copy it. That's a bummer. 5 minutes it ran for. I just canceled it. Oh, that's annoying. Cancel. We were on IMS of helpers. We were like halfway through helpers. Just kind of taking a stroll through the rest of these to see if there's any others that found wrong files to type check. Should also check one of the ones with directory to make an issue out of it and make sure that it that the slash doesn't get messed up. Gosh. I don't know why some of them have PyCache. Is that in the repo? It must be, right? I cloned the repos. ATEC. Not in there. Why do those get PyCache inside them? Doesn't have PyCache inside of it. Why did it find that? That's definitely odd. Or does PyCharm hide it? Maybe PyCharm hides it. Yeah, PyCharm hides it, okay. It's there. Close to the top now, so yeah, there we go. Okay, test and PyCache are the only two that I think I saw. So we added both of those. We'll save this. We'll drop a copy back into this repo. And I'll let it run one more time. And while that is working, I am going to step away for just a minute and run to the restroom, and then I'll be right back. Let's make sure that ATEC looks like it worked fine. ATEC looks like it worked fine this time. Okay, so I'll be right back, and then we'll see how long this takes. My guess is it only had like another minute or two, so probably 6 or 7 minutes total, something like that. Let me do this real quick. You. Okay. That went way faster. What happened? Helpers. Did it skip ones that were done already? Did it fail on all the ones that were done already? No, because we looked at ATEC. This 2 minutes 20 seconds. MyPy cache? Maybe MyPy cache. Maybe this made it go faster on all the ones that it completed before. Because I guessed that it probably had about 1 or 2 minutes left. And this time it only took that about 2 minutes, so I'm thinking MyPy cache sped up all the ones that got completed last time. It's gotta be it, right? What is, let's look for MyPy cache. See if there's any just like high level information on what this does. Run MyPy again. Huh. Yeah, I guess, yeah, that's gotta be it. I think that's gotta be it. Yeah. Cache stores it inside of MyPy cache. Yeah. Okay. So that's actually good to know, because we could run, now that I've run MyPy, I have a cache for every library. So if we were to run it again and make the issues, it would actually possibly go quicker. I mean, I guess it'll slow down some because it's going to be making the issue, which is like HTTP post and all of that stuff, I assume. So I guess like it would go way faster if I did it one more time, right? Would it be like under a minute this time? I'm gonna take my coffee cup. Yeah. Okay. And drivers. that 2 minutes is just about where it's at. Well, we're in helpers. I guess there's not as many helpers. We're already to helpers M. Util. Gotta fix that RSA util. Maybe I should go back to just printing what it found. Still. Tests. Tests. It is interesting that it found the ones in the library, even though tests is what it ran against. But it found one in tests also, which I think we care a lot more about the library code and test code. I mean, it'd be good to do both, but library code is the main thing we're focused on. There's another tests. Other tests. Just now we're back out to drivers. I think we should not print the list anymore. Not print the list. Also, this should be inside of here. Because if we don't find any types, any missing types, then we don't need to make an issue, which means we don't need to make an issue description. So let's not print the list, and then let's run this one more time. And just kind of keep an eye on if we see any other suspicious module or package names that we target. Good so far, I think. We're into helpers. Off. Okay, made it. And it's 1 minute 25 seconds when it has the cache. And I didn't see anything else that looked suspicious in there. Everything that I saw looked like it was the correct module or package name. So I think we finally got all of the known directories out here. So let's update this. And yeah, I think that's probably good for today on this project. I still need to tweak the actual template a little bit. And I don't want to run it today anyway. I think I'll wait and run it on Monday and just let folks know in the chat room before I run it, so that it's going to file a bunch of issues if it works, right? It's going to file an issue on almost every library if it works. So I don't want to do that just out of the blue over the weekend, right when I get it working or whatever. I'd rather give folks a heads up before that's going to happen. I think this is pretty good. I think we got it to where really we would just run after make issue description inside of here, we would just run, I think, os.system make issue. With the one change, I guess, being that this would now be missing types issue. Yeah. And if all of that works, then it will make an issue for each of these. I think, actually, let's check one more thing before I move on to the next thing I want to work on, which is, let's check one of the ones that was a directory. And let's paste it as an actual issue somewhere and make sure this slash doesn't mess up the markdown. No, seems fine. Yeah. Okay. All right. So yeah, I think the last two things to do are tweak this up. We're going to mention leaving a comment reply on the actual issue. I'm going to link to the contributing with Git and GitHub guide for folks that might be new. And yeah, I think that's it for the tweaks. I'll check back in the Discord and the discussion I had with Kattni, but I think those were it. We'll check on that. We'll make those tweaks, and then once we add os.system make issue at the end of this, I think it should go. I would still, I think, eventually like to try it on one or two before I run it on all of them, so maybe I'll try to figure out a way to get a bundle, a local copy of a bundle, and remove all but like the first two. Or maybe I'll remove all but one package and one module. Do that. We'll leave one package and one module. And then as long as those look good, then I'll run it on the entire bundle. And then I'll just go back to those two that would have a duplicated one, and I'll just delete one of the issues. Or close it, I guess. I don't think it gets deleted, but like those two will end up doubled up unless I take them out of the full run somehow, but I guess I could do that. Could take them out of the full run and they wouldn't get doubled up. But I think we're there. So I'm gonna update, I'm gonna push this repo. Let's see, did we make any changes to anything else in here? I don't think I changed the template today. Type annotations. I don't think I changed this, but oh yeah, we did change it. What did we change? Oh, right. We took out the took out that slice. Did that one. Updated that already. Yeah. Cool. I will not check in that. Yeah, so I think we're good here. Push. Implement. Run on. Oh, you know what else we want actually? We want to put the copy. Let's put the copy. Copy. Paste. Yeah. Command to run. I'm gonna put this also. Command is this is the wrong one. Okay. Add command to readme. Update. Make issue and make issue description. Okay. There's probably other tweaks we did, but it's good enough, I think. Okay. So we push that. All right, so I will make those tweaks sometime before Monday, and then I'll try out the smaller subset of them hopefully on Monday. As long as all goes well there, then I think we'll just run it on Monday. And I can get rid of this. I can just go ahead and close this. Okay. So next thing I want to work on is Blinka display IO. Basically, I want to take that branch that Les Samurai Porpe has started and just try it out and look at the new stuff and maybe do some testing. So let's set the stage a little bit. I have a Raspberry Pi right here. This is I think a Raspberry Pi B+. I have this SSHFS is a tool I found. SSHFS. I have this running, which is letting me mount the Pi as a directory on my local computer. So Pi mount, I have this Pi mount directory right here, and this is it's mounted using this tool SSHFS over to the Pi's home folder. So I essentially have a local folder on my PC that is actually mapped to the Pi's home folder, home Pi actually, /home/Pi on the device. And with that mapping, I'm able to open projects that are on the Pi inside of PyCharm. So this is a copy of the current Blinka display. Well, it's actually probably old at this point, but it's a copy of Blinka display IO that's on the Pi already. And just to show some of the stuff it can do real quick, let's go back to the camera. Inside of here, I have a file called clear screen. So right now it's running this ILI 9341 simple test, which is what's drawing this stuff on the screen here. I'm going to Control-C to stop it. And I'm going to run clear screen. Python 3 clear screen. So this will blank the screen out. You can stop that. I guess clear screen, we could probably make it, we could probably just make this not loop, right? Let's try that without looping. Python 3 ILI, simple test. This will run this. And after a second or two, it should draw all this stuff on the screen. And it works just like display IO in the core, essentially. You set up the display a little bit differently. You do release displays. It's kind of like if you were attaching an external display, right? You set up a 4-wire, you have the specific driver for your display. You give it the bus, you tell it the size, you tell it the rotation if you want. And then once you have the display object, everything else just works right like display IO does. You make a group, you call display.show on your group, and then bitmaps, tile grids, all of that stuff just works the exact same as it does in the core. Let's do a couple of things though, just to prove that this is working. Let's change the color of this outer border. Let's change it to green. I think that's what it was originally. And let's also center the hello world text. So do that. Color here. We want bright green back. Green. And to center this, we'll just use anchor point and anchor position. Text area anchor point 0.5 0.5 anchored position. These are not functions though, right? These are properties. This needs to be a tuple though still. And here we'll put display.width over 2, display.height over 2. Save that, and then let's rerun it. Let's run the clear screen actually. Let's see if that worked for... no, it doesn't work. Interesting. Does that not work? I wonder if it finishes too fast. Time is not defined. Time. Okay, there we go. So yeah, I think Blinka Display does some work in the background, and it must not have must have finished before it actually did the work in the background without the sleep in there. Now it's working though, and so now let's do simple test. So I'm connected through SSH to the Pi here, and it's all on Wi-Fi, so it is a little bit laggy. Not, you know, not 100% snappy, but it's good enough to get the job done. So we'll run this. Oh, we don't have we have two issues actually. The text is gone and the color did not change to green. Why would that be? So did it not work at all? Did it work and just have the wrong color? Let's take out scale. Okay, hello is way down there. So anchor point and anchor position are not working, and a lot of this stuff that I'm running right now is very, very likely out of date. So maybe there was some kind of issue that has been resolved, hopefully. The green, though, is throwing me off. I don't know. Oh, RGB. I did this backwards. Right, green is here. Yeah. Green is in the middle. Yeah. Okay. So anchor point and anchor position are definitely messed up somehow. But the colors are working. So to start with, let's just what do we want to do? I think we want to let's get the current Blinka display IO. Because again, mine is very likely out of date, and my display text and everything else. So let's get the current one and see if it's still broken on that one. And then go from there. So main. I think what I'll do is let's go up. Well, we gotta stop this running. Up. we're gonna git clone link a display IO. And I'm gonna open that. You could see I have a bunch of copies of this. I need to clean them up, but okay. So now we have updated Blinka Display IO. So I'm gonna bring in this already SSH'd? No, it wouldn't be SSH'd, right? Be SSH'd? No. The Pi has Python 2 on it, so that would have ran Python 2. Yeah. Okay. So inside here, copy bring the simple test over to here. And let's just try running it. Let's do the clear screen. I guess let's bring clear screen over also. Okay. I think this may fail. Not really. Okay. So max size is deprecated. Oh. This is changing the location right here. This is changing the location. Yeah, that was it. Max size, we still have max size. Hey, List Samurai. Yep, we're checking out, we're gonna be checking out your Blinka Display IO branch. I noticed some weirdness with the location of the text, so I wanted to run this on the stock branch and just make sure that I understood what was going on before I start diving into the new stuff. I think I just didn't save, honestly, this. If we run this again, we don't get that, right? How do we still get it? How do we still get it? Get it because inside of display text? Inside of display text? Size, we don't find it anymore. Gotta be inside of display text, right? So let's go quit, let's go. Oh, that is a touch too big. Why is that so big? I do 30 instead of 3? Oh, that's scale 3. Really, scale 3? I know there was a bug at one point that made the scale off by a factor. Is that what we're running into? Or is that actually the right scale? I don't know. Honestly, it looks like the anchor point and the anchor position are wrong as well. Okay, let's get the newest display text. Let's get the newest display text. So let's just go to display text here. I want the pip name. Pip show. Pip 3. Huh. There we go. Okay. 292. 221. 0. Okay, yeah, we definitely got quite a few. Pip. Is it install upgrade? So SSHFS Roxy. Yeah, for real. I didn't know about that thing until today. I found this thing today because I was like, how can I, there must be a way for me to be able to open the directory inside of PyCharm. And that's what led me to it. Okay, so we're up to 21 now. So let's go clear screen. Let's put the camera back. See if our text is still off. If the text is still off, then it doesn't matter that much. It's not what I'm really interested in looking into. But I would like to know if it's off. That way, like, if we see it in the new one, we know, okay, yeah, it's fixed. It's fixed. That was just a old display text thing, already got fixed in a PR long ago, I'm sure. And the scale is better as well. Scale 2 is actually scale 2. At one point in time, we had a deal where it was like, we were off by 1 on the scale, or it was like doubling or something. Like if you set it to scale 2, you actually got scale 3 or maybe scale 4. I don't remember the exact deal. Basically, you got a bigger scale than you asked for, though. Okay, so this is all looking good. So this is the stock blanket display IO. Everything looks fine here. Now we're gonna get the fancy new one, which we will grab from the issue. Hey, thanks for working on all this stuff, by the way, Lay Samurai. This looks awesome. I saw this go by through the week, and I didn't notice exactly how much you really had done until I started looking into this today. But this is awesome. Like, to have Vectorio, Vector.io, and bitmap tools squared. That's what it was. Okay, yeah. This is really cool, though, that you did all of this. Thank you a bunch for working on this. This is awesome. So we want to get this branch. I think, can I clone this branch? I guess I can clone it and then check out the branch. Clone it and then check out the branch. Let's go, we need to stop. Let's go up. I'm gonna continue on my, just making copies of this without ever cleaning it up, but that's all right. We'll just call this one real for right now, or stock maybe. So now we can go clone the new one, which is from your fork. So we're going to get main by default. And so we're going to go inside of there. Actually, I'm going to change the name of it before I even start. Sam new. I think I have LaySam already. I think I had one of your copies from when I did a PR test or something. But this is like rewrite new, all new, everything. So let's go inside of it. Okay. And then checkout. Get checkout. Was it display core, I think? Yeah. Display, whoops, core. Switch branch, okay. Okay, so now let's go, yeah, there's bitmap tools I can see already, and vector IO as well. So let's go, let's grab the simple test. CP. Stock. Yeah, simple, no, well, it's ILI. Move it to here. Let's get clear screen also. Clear screen. Oh, I gotta go feed the outdoor cat. I'll be back. Okay, sorry about that. We have a cat who hangs out outside that goes into our neighbor's house at night to sleep in the basement, and then is usually an outdoor cat besides nights. And she has figured out that she can scratch at the glass door, and it makes a god-awful squeaking sound and gets my attention to come and give her food. And it works perfectly, because it gets my attention, and I come and give her food. So I am very well trained by the outdoor cat. Okay, where am I at here? So I got clear screen, I got simple test. Let me get the camera. Let's clear the screen. Python 3, clear screen. Python 3, clear screen. Brightness not adjustable. Okay, so that's one difference. Let's open this up. Also, this changed. I guess all the code is gone. Mount. Let's go new window. Let's break out of SSH, close this. SSH back. Doesn't know the right size anymore. Okay. So now not inside of here. This should be the same error, right? Yeah, brightness not adjustable. So that's one difference is, looks like display.brightness is not implemented yet. Let's comment that out for now. Yeah, yep, we're good past that. Let me this real quick here. And I suspect is there brightness in this as well? Yeah. Let's see if it works. It is weird. I feel like I discovered this long ago. I should have left a comment or something. I think brightness was inversed or something, maybe. Brightness 1 was making it off. Brightness 0 was making it on. I don't know why I would have been setting the brightness to 0, but I assume I must have found that that was what I needed to do to make it work in the old one. Let's run this. There we go. It seems like it's working. It's a little slower, but I know you mentioned on the oh hey, we have a different font. Does that match the core font now instead of, because I know we always had a different font for Blinka Display IO. I know you mentioned though ways to speed it up with taking better advantage of NumPy and Pillow. It's the core font. Oh, that's awesome. That's really cool, actually. That was always one of the things, like, it's never a huge deal, but I did notice that we always had a different font for Blinka Display IO, so it made it so when you run, if you write something and you run it like in the Pygame display, or you run it on Blinka on a screen like this, it would look a little bit different because like the size of the font was a little different because it's just a different font. So let's test out. So you said there's shape, which I think this does not even exist in old Blinka Display IO. Yeah, there is not a lot of example code for shape. That's another thing that's kind of on my infinite list of things to do is write sample code for shape and vector IO as well. Honestly, I think we should have a new guide page in the Display IO guide, but okay. So let's go new file. You know what I'm going to do is I'm going to make a file with just the display setup, and then I'll make the rest of my files from that one. Display setup. Because it's got kind of a lot of stuff that needs to get done to set up the display. Why is this back to half? Oh, this is half, right? Actually, I could start with clear screen. That does most of it. And then just don't make a group and show it. Actually, I'll make a main group. I guess I will make a group and show it, actually. Let's call it main group. Main group. And then let's take out the sleep. Let's put back the while true. And yeah, we could at this point just add stuff to main group. And it should get shown on the screen. Okay, so let's take display setup, copy it, and make shape test. I wish we could have examples in Blinka Display IO repo. The part that makes it difficult though is you have to use different initialization code for every different screen, right? So if we put examples, they're only going to apply to one screen, or Maybe we put comments and you uncomment the one you want or whatever. Maybe we put the most common ones, 2 or 3 most common ones or something. But like it won't work across the board, which is a bit of a bummer. But I do think it would be nice, because right now you have to go and find like the simple test from inside of the driver library for your screen, and then you have to change the pins it's using, because the simple test inside of there is expecting a microcontroller which has, you know, most likely differently named pins. So there's not like a full example of like, this example is just ready to run on Blinka Display IO that I'm aware of, at least. It'd be nice if we could put that in the Blinka Display IO repo. Maybe I'll make an issue and some PRs for that, even though I just have the one screen hard-coded, but I think that would be really nice if we could do that. Let me see here. Put the chat back, okay. So shapes, yeah, I don't recall off the top of my head how shape works either. Honestly, I usually go back to the same place you got it from. I did use shape recently in grid layout to make the grid lines. Look at Display IO running with shapes. Let's get that playing. Move this over here. Whoa, nice. Awesome. With shapes background. Is that like a full, well, it's probably not a full screen bitmap. Is that like a bunch of circles, basically? Like circles that are wider than they are tall, and they're just placed concentric or whatever, right? There's just a bunch of them that are all different colors. Is that how that's set up? Polygons. I got you, okay. Nice. Looks like the updating is plenty fast as well for changing the text. I don't know if mine was, well, the screen I suspect is probably bigger, at least more pixels. Maybe, I don't know, maybe these are tiny pixels. Mine took a minute to load, but I guess it's better at changing small sections. Because did you say you did 30 section tracking, right? Back to here. Yeah. Okay. So that's a really cool thing as well. We didn't have that. I don't think in the old Blinka Display, I don't think we had that yet. It had like some of the infrastructure for it, but it basically just counted the whole thing as dirty, if I recall. Exact copy. Nice. That's awesome. That is awesome. Yeah, that's really cool, actually. I want to try some tile grid stuff with Pygame display. One of the things I noticed is that it's a little slow to update, but I suspect it's because of that dirty rect stuff. I bet it would be better with this one. So let's make a shape test. I think could copy some of this stuff. We'll change it up once we get it running. Y in range height. Okay. So I guess this is, it's been a while since I wrote this. I don't remember exactly what it does. Looks like it's gonna make a really small one and then increase the size until it gets to 100. So we need a tile grid. We already have a group. So we'll just go main group, append tile grid. This is changing the height some more. Set boundary. What does set boundary do? Why? What? Loads pre-packed data into the given row? Set boundary. Is that right? That feels like it's a different function, right? Or is just the name of that function kind of weird? Let's go the docs. Actually, let's go to this page. We found a few weeks back that's really nice. But I still only have bookmarked in Chrome. Shape. Does the same thing here. Huh. Let's get back to this chat. Let me pull this other chat back. Docs need improved. Yeah. So loads pre-packed data. Y start X index. Loads pre-packed data. Is that X index boundary. Start X index. Start X index. What is the pre-packed data though? Is it's used for making rounded corners, is that right? Presents a shape made defining boundaries that can be mirrored. Shape object with the given fixed size. Each pixel is 1 bit stored by the column boundaries of the shape on each row. Each boundary's default is the full row. Yeah. Well, okay, one thing you could use it for is rounded corners, but I guess you could make, I suppose you could make lots of different things. It's basically choosing the horizontal direction that, well, it's choosing the horizontal line that will count as foreground versus background. Let me check on something real quick. That's weird. Okay. Just ignore that for now. You have a shape test as well. Is there a copy all? Download. wow, the scrolling is so slow. I don't know why it's like that. So I guess the name is probably fine, set boundary. Maybe the description should be, because there's really nothing about prepacked data, is it? I mean, we're not passing in data that's been packed. We're passing in the row that we're interested in, and then we're passing in the start of the row, the end of the row that we want to be foreground, which is that prepacked data? I feel like prepacked data implies like, you know, like we'd be copying one row out of a bitmap or something. You're right, though. It is not, it's tough to think of a great way to describe it. Your pack suggests multiple rows in one buffer. I could see that as well. I don't know why this has image load. Doesn't need that. Terminal IO either. I guess those are in clear screen and I must have copied them over. Let me delete those real quick. I'll keep time in case we use it later. Okay. Let me see what this does when I run the one that was from the PR. Through. I guess I maybe miscopied. I think we want one more. I don't know if we want this to be a full second. We'll see how slow it is. Okay. We are currently running that. Let's break out. Shape test. Whoa. I don't remember at all what it's supposed to do. Okay, let's start simpler. Let's start with, let's just make a shape and not mess with the boundaries for now. And let's put it in the middle of the screen. Okay, let's break. Let's get rid of this. This should make a shape that's 100 by 100. And I guess probably put it in the top left, since we didn't set an XY here. What about the background? Palette 1. Surprised this didn't error, right? That should have been like an indentation error, shouldn't it? We didn't get anything. Palette 1 is teal. Palette 0 is blue. No mirror. We have width and height 100 by 100. Display is scale. Scale. This is too big. It's too big. Yeah. I don't want this. That's definitely gonna make stuff look weird. Take that out here as well. Then, right? Yeah. That's copied to a few places already. Okay. So interesting. We're in the bottom right, but honestly, my camera is all turned around. Is that actually the bottom right? But let's move it some. Let's go tile grid X 50 and Y 50. Okay. So is the origin different? Is the origin, well, the origin on like a Pi portal is top left? Is that right? I think so. And this, I gotta get up and turn and look. Let me see here. Huh. Yeah, it feels like our origin is bottom right. Do I have a rotation or anything? Yeah, mirror false. Ah. Yeah. Yeah. Means this is also in here probably. Should have looked at this closer before I copied it all around, huh? There we go. That's making sense now. Okay. It doesn't help that like the Pi is technically backwards from me. It's actually facing the other way, and the camera's turned around so that it's right way up in this view, but it was a bit too many flips for me to wrap my head around. But that makes sense though. Rotation 180 would have made it so bottom right was origin. So the actual origin is top left, which is correct. Now we're at 50-50 inside there, which is making sense. And right, so this is not, yeah, okay. This is coming back to me a little bit. This is not like changing the shape. I mean, these ones, I guess, would be changing it over and over again. It's looping through all the rows, setting the boundaries. So we would end up with 30 pixels of, I don't know if it's foreground or background, but 30 pixels of one and then 70 pixels of the other. Yeah. Yeah. And if you want non-rectangular shapes, you could also do like 0y. Wouldn't this would make a triangle or something? Should move it back to origin maybe. Yeah. Yeah. Okay. That makes sense. And then this was just going from, okay, yeah, this is coming back to me now. So this was basically just going between what we saw before with 30 here, going between that and one that's just bigger, that's 80, and then back and forth. So that does make sense. Yeah, I really need to go and, oh wow, yeah, and you can see the, I mean, that has to be the dirty rect stuff picking up, right? Because this is now going way faster than it was to render the whole thing there. Sweet. Okay. Okay, let me try yours. Their shape test. So let's see what we have here. Okay, let's fix this. Play width and height. This is making the shape full size. So one thing you can do, I think, one of the tricks of this are these ones. If you want to be full size like this, I think if you use, I'll run this before I make any changes, but I think if you use over 2 and over 2 and then put these to true, I think it's more efficient. I'm not 100% sure if it's like drawing speed or memory or what, but I think that those mirrors, they allow you, especially when you want to make a rectangular shape, you can do half of it and then mirror it. Well, but maybe the mirror would get weird with the boundary. I don't know how the mirror interacts with the boundary. Oh, grid, okay. Width, okay, this is pretty close to the same, basically. It's just using the full size of the screen instead of 100 by 100, looks like. So Python 3, another. X is out of bounds. Width over 2 plus y. We just need -1. So width and height, did it print? Yeah. 320, 240. So it would be 320 over 2 is 160. Plus y would get up to 240. 240 and 160. Yeah, that's 400. Right? Yeah. It's 400, so it does get bigger. So is this supposed to be height, maybe? Looks like your screen was more rectangular as well, though, right? Like, I think your aspect ratio is more rectangular, which maybe helped you not run into this error. I'm not sure. Or should y be over 2 as well? Not sure what it's trying to do. Y, that's going to get up to height, which is 240, which means we can't add anything more than 240 minus 160. We can't add anything more than 80. So if this was over 3, would work. Maybe still off by 1, I'm not sure. Yeah, maybe still off by 1. No? Your width and height is 160 and 80. Okay, so you're double. You have double the width that you do height, whereas this is 1/3. Well, two thirds. 320 and 240. 3/4, I guess. Yeah, 3/4. This is out of bounds. So -1. That should always be in bounds. It's over. Is it supposed to be over 4? It's supposed to be over 4. Yeah. 4. I don't know if we need -1. There it goes. Okay. Whoa. It might be. I wonder if it's sleeping. It's like it looks like it's sleeping before it finishes the full wipe. I wonder if it's not done refreshing before it sleeps here. I don't know if we have a way to like wait without sleeping though. Kind of cool looking though. Okay. Let's make a let's do a display text test, and then let's do a little bit of vector IO stuff as well. Let me go setup. Just call it label test. What is the issue? They never wrote back. We could probably close this. Yeah. we'll retest it, but retest it on, we have stable 7 now, so we could retest it on stable 7, and as long as it doesn't do it, we could just close this, leave a comment that says if you run across it again, then reopen it, post some more details, but since they never wrote back, I think we're probably okay. Let's go simple test. We'll need these. Oh, I called this label setup. I should have done label test. Test. I'm curious to try this with the Pygame display as well, kind of. Display show. Not gonna show it, but we're gonna main group. Whoops. Pinned text. There we go. Label looks good. It's exactly like it's supposed to. Scale equals, how big can we get before it's too big for the screen? Is 5 too big? Just kind of interested in playing around with some of this. The clock code with the polygons. Oh, nice. I wonder if there's a way. I wonder if there's a way that we can like separate the display setup code from the code that's actually doing whatever it's doing, right? So that way we could each just have our own display setup and we could pass along a script that doesn't include it. We should be able to do that, right? We could refactor it out like we make a file called display setup and it has a function that, I mean, we call it whatever we want, but it has a function that will do all of this, create the display object, and then return it. And then in our other scripts, we have like from display setup, import setup display, we call it, we get the display object, and then we just have the business code, like whatever we want to actually do. And then that way we could have different setup displays for each different screen, and then all you have to do is just put the correct setup display for your screen on your Pi, and then you could just run the other one and it would be like independent. It wouldn't care about the screen. Does that sound like it would work? Could specify, yeah. Yeah. Yeah, I think we should do that. I think we should try to standardize that. Because it would ease up the, like, it would get rid of all of this stuff, basically. It would put that in its own thing. It would be super easy to swap to a different screen because you would just import, you would have a different copy. There'd be one of these for each different driver. And you just drop that in, and all of your actual like test code, business code, drawing stuff is now agnostic. It doesn't care what the screen is. It's not having any of this. I think that'd be really cool. Yeah. I think that'd be really cool. That would make it a lot easier to have example code in the display, in the Blinka Display.io repo as well. because then all the example code can just import that thing and use it, and then the drivers can have that file that it's importing from. And we can leave a note in the examples that says, like, you know, go find your driver, get its setup script, its display config, and paste that alongside, and then just run the example. Yeah, I'm gonna probably try to set that up. I'm not gonna do it right this second because I'm so excited about playing with this, but I think that would be a really good way to organize Blinka display IO code so that it can be agnostic to the screen. Now though, let me take your example. Let's go, this is what, clock, I guess? Clock, right? Clock. Test. Fine. Doesn't really matter, I guess I'm not gonna push any of this. I should have done setup, huh? Cool. Oh. Highlighting with the scroll wheel does not work very good. Discord. Well, in Chrome inside Discord. Maybe it's better in the app, I don't know. Ooh, okay. Vector IO polygons. Rainbow IO. So we'll need to fix some imports here. Oh, you have a separate font. I'll just use terminal font for now. Terminal IO font. And I think the deal here is that my local copy of Blinka Display IO on my PC does not have this change yet. So it's not finding it, but inside of this project, when it runs, it should be there, right? Because well, no, it doesn't exist here. Is it? It would be in Blinka, though. It would be in Blinka, I think. So maybe it's, I might have to update Blinka, actually. I'd have to update Blinka. Let's give it a try. On the Pi, that is. I'd have to, well, I probably need to update on my PC as well, but. Clock test. Yeah. So pip show, no, pip3 show, just Adafruit Blinka. Massive tangent, I vote for renaming secrets. Yeah. Yeah. You know what I saw that I would also be down with is, where did I see this? This was on Whippersnapper. When you set up Whippersnapper, so like this is kind of separate from CircuitPython, right? Because the Whippersnapper, like the whole idea of Whippersnapper is like codeless projects or whatever, right? So you're not writing CircuitPython code. But when you set up your device for Whippersnapper, you put it on CircuitPython so that it's a drive, and then you go to your drive and you make a secrets.json file with all of that information in it. And then you switch it over to the whippersnapper UF2, and it looks for secrets.json and it imports things from there. I would be fine with keeping the secrets name if we switched it to JSON. But yes, we need to stop secrets.py because it's a built-in module. Like, and I suspect I've thought about this. I think I've mentioned it before as well, and it's kind of like it would be a lot of work to change, which is true. I think the thing that would force this to actually happen is if someone came along and was like, hey, I want to implement a subset of this module, because this is the problem, right? We have secrets.py for, Wi-Fi network name and password and, API keys and all of that stuff. And therefore it becomes a problem with when you're running in Python 3, you can't have a secrets.py that is that stuff because this is a built-in module. This is the name of a built-in module inside Python. I think if someone came along and made an issue or started a PR on the core that was like, hey, I'm implementing a subset of this, CPython module into CircuitPython, and it should obviously have the same name that it does in CPython, I think that this would be the thing that would, in particular, get Scott to try to hopefully get the rest of the team to pull the trigger on renaming it. Because if we wanted to make this in the core, right now we have basically two choices. We could either name it something different, like CPython secrets or something, right? Like name it something other than secrets, which would not be good because then the code would not be compatible with CPython. Or the other option is name it secrets, but we have to go back and change everywhere where we've used secrets.py for like credentials and stuff. And I suspect that, I don't speak for him, so I don't know for sure, but my guess is that Scott's preference would be to keep this with the name secrets. That way the code is actually compatible. And since it would be a subset of CPython, like, that's exactly what we do whenever we implement something that's also in CPython, is keep the name of it and then have a subset of it. So I suspect that would probably be the thing that would be like the driving force behind it, is whenever someone comes along and wants to implement this in CircuitPython. I think the libraries, there are probably quite a few. I think lots of the, like all the PyPortal libraries, although the thing is, like, Melissa's done a good job refactoring it, Portal Base might be the spot where all of it comes from these days. I don't know exactly how the refactor looks inside of those, but I think that's one of them. Maybe Adafruit.io library, maybe ESP32 SPI. I'm not sure. That one might be low enough level that it wouldn't care. Like, you might pass the secrets into it, not having it like actually try to find the secrets. But I think probably Portal Base, maybe the ones that use it, like the PyPortal, MagTag, maybe those. I don't know if they need it at that level, or maybe if it's all inside Portal Base, that would make it easier if it is. Adafruit.io, maybe like, oh, what is that? What is the protocol that Adafruit.io uses? It's like the sort of real-time subscriber feed protocol. MQTT, maybe that library. MQTT maybe tries to import it. Requests, maybe? Adafruit requests. That's probably close to it as far as libraries. There's probably a lot of project code, though. And aside from actual project code, there's also a lot of guide pages that would need to change, which that would be probably, honestly, the bulk of the work. Like, the project code, we could always iterate over the learn guide repo, find everything, and like, automate changing it probably, right? We could just rename the file, or we could do something, change the import if it's there. That could probably be done relatively like automatedly, and then we just make a big PR with all of it done. But the actual learn guide pages, there are going to be a ton of pages that say, that like give the instructions on how to make that file and what to put in it and stuff like that. And essentially every single one of those would need to change. And I don't think there's a super easy way to change learn guide pages automatically. But yeah, it is a tangent, but I totally 1,000% agree with that, that we need to change it. And it's going to be rough to do, but I think it's a Band-Aid that has to be ripped. Like, someday we're gonna get to the point where we want to implement this, and we're gonna have to make the choice between those two things: either not having the name that shares with CPython, which is not a great choice, or fixing this, like going back and renaming it and just slogging through all of the changes that it's going to take. And those are really the only two choices, and neither of them are great, but it is where we're at. If we change to the JSON, though, which that's what I noticed about Whippersnapper, is that it used secrets.json, then we don't have any kind of problem with import. Like, we never camping on a name that we're importing because it's just a JSON file. And it's not like secrets.py basically just holds a dictionary, so it pretty much is JSON anyway, right? It's not technically JSON, but it might as well be, honestly. Okay, so we showed this. We were on 1.2.9, which I'm guessing is probably quite a bit out of date. Oh, come on, why? Oh. 6.13.1, yeah, I'd say I'm a little out of date. Did I do the right thing? Wow, this is very, very old. Okay, so let's go install, upgrade. Gotta spell it right, though. Here we go. Got 6.13.1. And my local copy still is not updated, so I think PyCharm still does not know about this, but the Raspberry Pi should know about it now, I think. Yeah. There we go. Nice. Hey, that's a cool effect. Are they, what's that look like? Is it actually moving? Or is that just the camera being weird? Yeah, they are moving. Changing the points. Hey, that's a cool looking effect. I like that. Only library that secrets is hard-coded as portal base. Oh, that's good. Yeah, that's good. Oh, they should be static? Huh. Just the camera doing that? Let me look. Let me go around the way here and look at it. Right at the screen. Oh yeah. Not doing that. It's not doing it on the screen. So it's just an artifact of the camera. That's cool looking though. I wonder what it is about this drawing that makes it do that. It's interesting. Huh. Wild. Okay. Sweet. Yeah, this is a cool example. I think probably your font is just bigger than mine. We could do scale. Does it have extra spaces in it? O2. Or why it's all stretched like that. Is it, we did scale bigger? Scale 3? Is it gonna be stretched off the screen now? Oh. Huh. What to span the screen with, I see. This is weird because it started drawing it. Like we can see the tippy tops of each of those got scaled up. Refresher. Refresh display. Fill area. Ah, something was none. Absolute transform was none for some reason in this case. Why would that be, I wonder? Does it matter which number we use? Should have done clear screen. Yeah, it looks like scale 2 is fine. Interesting. Maybe getting divided out to 0 somehow? Is it just a fluke? If I run it again on 3, does it work? I mean, surely that's not. Let me clear first also. Let's go clear. Clear. Occasionally getting that error. Ah, I gotcha. Okay. I think the fix is thread synchronizing and locks. Okay. So it might just work this time then. No? Same thing. Let's try one more. Let's do clear again. Does it fail at the exact same spot? Let's see. Yeah, it does. Huh. So I'm curious, if we go 4, does that make it better? I don't know if we have enough room for 4, but let's try it out. It's clear. Well, okay, 4 made it farther. Made it farther. Interesting. Go to 1. I should have cleared. Oh well. Yeah. I guess N2 seemed to work all right as well. And the update's nice and quick. It's pretty cool. This is just making ellipses by adding up points into a polygon. Nice. Ellipses. 16 chords. So if this was higher, they would be more rounded, is that right? It's like, it's kind of like the fineness value in OpenSCAD. Yeah. It's like double the number of points on each one, basically. That way the lines that they make up are closer together. Cool. And then ellipses, this would make more actual circles. Wonder if there's a limit before it starts getting mad. Or are there, I should have done clear. Maybe there's not enough colors also. Let me do clear. Yeah, enjoy the pizza, and I'll make an issue. So far, the only one I found is that scale one. Get it again? Oh, we got it again. Okay, so somehow it's related to these numbers as well. You're probably right. With the way it seems kind of random, it's probably related to threads and the timing that stuff takes. Pretty cool though. I'm actually going to get ready, I think, to head out as well for the day. Been going about a little over 3 hours, so usually about how long I stream. So let's take a look back. So we worked on the typing finding. I'm feeling pretty good about that. We got pretty much all the way done with the last part of that we needed. So I think we'll be ready to run that this week. I think the plan, and again, it's going to be on Monday. I'll let folks know that I'm going to run it, and then run it, you know, probably sometime before the meeting or something on Monday. And then, meeting on Monday? I don't know if it's Tuesday this week. I don't think so. And then I checked this out, and so there's obviously still a lot to look into on this. Yeah, take it easy, Lay Samurai. Thanks again for working on all this stuff. And yeah, I will be. My plan is to stream on Friday evening. So yeah, I'll catch you then. This is really cool. I'm excited to keep I'm excited to keep digging into this as well. I'll test out bitmap tools at some point. I'll play with vector IO a little bit more. This one's using it for polygon. So we did technically test it, but I'll test out a couple others. We'll do some circles. We'll do some rects, and I think is there a line maybe as well in vector IO? We'll play with some of the other non-polygon ones at some point as well. But yeah, this is really cool. Huge thanks again to Lay Samurai for working on this. I think this is going to be hugely beneficial to Blinka Display IO. Yeah, this is really awesome. It's really awesome. All right, so yeah, I'll be back. The plan is this week I'm going to stream on Friday evening because Scott's got the day off. So normally Scott streams at I don't know the time in Pacific, honestly. Normally Scott streams and it starts at 4 p.m. Central, which is my time. He usually advertises it in Pacific because that's his time. So I guess 2 p.m. maybe Pacific, but I'm not 100% sure if that's right. But 4 p.m. Central is usually when Scott's stream is at. He's going to be gone this week, so he's not going to be streaming. So on the 1st of October, I will stream, but it will be 1 hour later. I can't start at 4 p.m. my time. I got to start at 5 p.m. So 1 hour later than the normal deep dive, I will stream. If folks are interested, you can catch me at that time. I'll drop a note in the chat as well, and I'll ping the deep divers role, just as a heads up to folks. But then. Aside from that, I'll just be back on Saturday morning at 10 a.m. Central Time. That's my usual time to stream. So I'll be back next Saturday, and every Saturday that I don't have something else going on, I'll be on at that time. So thank you to everyone who tuned in. Thanks again to Lay Samurai for working on this. This is really cool. Super excited about it. And I will catch everybody next week on Friday evening if you're interested, or Saturday at the normal time.